Hi, I am Renuka Jadhav and today we are discussing about some basic concepts of spectrophotometry. Now we have moved towards the introduction. Spectrophotometry is a method of analyzing that involves how light interacts with the atoms or molecules in a sample. Visible light is only small portion of the entire electromagnetic spectrum, and it includes the colors commonly observed: red, yellow, green, blue and violet. The visible spectrum consists of electromagnetic radiation whose wavelength range from 400 nanometer to nearly 800 nanometer. Now we are discussing about electromagnetic spectrum. So the electromagnetic spectrum is the distribution of electromagnetic radiation according to energy, frequency or wavelength. The electromagnetic radiation can be described as a stream of photons, which are particles traveling in a wave-like pattern, moving at the speed of light. So now we are discussing the electromagnetic spectrum in detail. The types of wavelength range. So the gamma rays having range less than 1 femtometer. X-rays, the wavelength range is from 1 femtometer to 1 nanometer. For ultraviolet region, the wavelength range is 1 nanometer to 400 nanometer. For the visible region, the range is 0.4 micrometer to 0.75 micrometers. Means it is from 400 nanometer to 800 nanometer. So generally in spectrophotometry we are deals with this region, that is visible region. So the infrared region is divided into 4 regions, that is near infrared region. The wavelength range for this is 0.75 micrometer to 3.0 micrometer. For mid-wave infrared region, the wavelength range is 3.0 micrometer to 6.0 micrometer. For long wave infrared region, the wavelength range is 6.0 micrometer to 15 micrometer. And the last infrared region is extreme infrared region. The wavelength range is 15 micrometer to 1 millimeter. The micro and radio waves wavelength range is, for this region the wavelength range is greater than 1 millimeter. Now we move towards the next concept, that is complementary colors. So this is a very important term in spectrophotometry. So first question comes in mind, that is Why do some substances appear colored? So some substances are colored or colorless. So if the substances are color means it will absorbs or transmitted the visible light. Some substances are colorless means all the light is transmitted through these substances. If the substance is white means the light is reflected. All the light is reflected. Then and then only the substance is white. Now here we are going to discuss one example, that is, if the sample appears purple colors means it will absorb all the light or the all the colors of the light except yellow color. So that yellow color is transmitted through that substances. Why? Because purple and yellow are the complementary colors. So that's why if the substance is purple color, then the yellow color is transmitted. So now we discuss in details. Here you can see the primary color is yellow and the complementary color is purple. So here the remaining all the colors of the light is absorbed by the substance except yellow. Then you can see the substance color is purple. If the substance absorbs all the colors of the light except blue, then the color of the substance is orange. So here the complementary color of blue is orange. Similarly for red, if the substance absorbs all the colors except red, so red is transmitted, then the substance appears in green color. So here the complementary color of the red is green. So now we discuss about the Lambert's-Beer's law. So this is a very important law in spectrophotometry. So this law state that is a linear relationship between absorbance and concentration of an absorbing species. The general Beer's-Lambert's law is usually written as A is equals to A lambda into B into C, where A is the measured absorbance, small a lambda is a wavelength dependent absorptivity coefficient, B is the path length, and C is the analyte concentration. When working in concentration units of molarity, the Beer's-Lambert's law is written as A is equals to epsilon into B into C, where epsilon is the wavelength dependent molar absorptivity coefficient with units of per mole per centimeter. So here The absorbance is directly proportional to the path length and the concentration. So this is the Beers-Lambert's law. If we change the path length, then the absorbance of the substance gets changed. If we change the concentration of the substance or varying the concentration of the substance, the absorbance of that substance get changed. So the absorbance is directly proportional to the path length and concentration. If we change the path length or concentration, the absorbance get changed. So now in the next video we are going to discuss about the detailed instrumentation of spectrophotometer. Thank you for watching this video.